this. So the reason why there's a bit of a disruption is because, long story short, someone requested because of their absence if I can do that. So here it is. Sorry for the delay. Let's get started. I am still marking your test, so you're gonna have to wait for me. But in case you didn't know, I actually have something to show you in regards to, if everyone got a chance to look at your Brightspace, you would have seen, I posted a whole bunch of resources that you can use. Long story short, if you are having some trouble or you want some more practice or you need a soundboard or someplace to talk to or whatnot about the material, you need extra questions, whatnot, there are a whole bunch of things that you can tap into. Paper, BrainFuse, and TVO Mathify are all online tutoring services. And so that they are affiliated with TDSB apparently, or affiliated with the Ontario government. So you can use them. TVO Learn also has a full math course. So share this tab instead. Full math course that you can dive a little deeper into. There are full video lessons that if you missed a class or you wanted a better refresher and whatnot, you go in there. It's all divided into different topics. You just have to sort of find your unit based on what we have done. So we're here right now. And there's videos, I think practice questions, a whole bunch of stuff that you can use. Okay? And in particular, if you don't have access to me for whatever reason. Okay. Lastly, Khan Academy, you already know. And yeah, that's it. Any questions about that before I begin? No? Sounds good. Let's get to it. So here we are. Fresh start, chapter 2. Everyone has finished their unit 1. So it's like a good idea of where you are. Once I finish marking, I think based on where you stand and whether you're happy or not, I think we can have a deeper conversation about what to go from here. And once again, same thing as always. If the strategy is something that's not working for you, let's dig deeper. If you truly have done your absolute best and it's really, you think, going to be detrimental to the top 6 because you have post-secondary as part of your plan, we got to do something about it. Okay, post-secondary, if you want to follow the recommended cutoff percentage or whatever, it's pretty competitive. It's probably dying down a little bit because the inflated marks post-COVID are starting to even out. If you didn't know, I would be first to say on record that the marks that a lot of high school students went into university with over the past 4 or 5 years have been very different compared to, let's say, 10 years ago, right? Let's say U of T Life Science, the cutoff was 85, 86, or even 87 on their magazine. Over the past 5 years, the recommended cutoff that you want to aim for was like in the mid-90s because the marks were so wonky depending on the school. Yeah, so again, just not to go too deep into it, there's things that we should talk about if you are not where you want to be after the first chapter. All right, starting off, I want to give you a heads up of what you can expect for the week to come. If you look at the board, I've updated your MHF4U schedule for the next 2 weeks. We have 2.1 and 2.2 covered as a big unit. This big unit is going to be today, tomorrow, and Friday. That's 2.1 and 2.2. And it's going to broadly try to arrive at a theorem that's super useful. And I'll tell you a little bit after. There's going to be a quiz on the Monday. Okay. On the following, the next day after, the Tuesday, I am going to give you an assignment as a class. And as of right now, you can work together, you can work alone, you can do whatever you want. The assignment is going to be due on Friday of the same week. That assignment, I forget whether we will ask for one set of answers per group, or whether if you work in a group, I still want one from everyone, I forget. So I'll remind you later. And then the week after, we should be done chapter 2, which means we'll have this. If you're still not quite sure about what to expect, there is that calendar that I have been creating for you. You can check Brightspace. It should be in the, I think I put it under Unit 0. Go check out Brightspace. All right? So without further ado, unless there's a burning question you have, let's talk about where we're going for today, tomorrow, and Friday. Questions? Okay, let's get to it. Chapter 1, we looked at how we can best look at an equation and have a picture of what the graph looks like. And up until now, we tried to give you nice numbers so that when in factored form, you get your x-intercepts. Super easy, super straightforward. The next question is, okay, what if we don't have nice numbers? That's the next bit. So in short, chapter 2 is the same concept as chapter 1, but we're giving you more tools to do the same thing more effectively. It involves long division. And using this long division, it's going to arrive us to a shortcut that's so much easier to do than for long division. That works for a certain situation. We call it a theorem. It's called the remainder theorem because it always works. It always works. It always works. Yeah. Okay, let's get to it. Starting with, I'll try to be fast because I have to let you go in 45 minutes. Short class today. Recall that long division means, let's zoom in a little. I have a 4,583 as a dividend being divided by 12. Well, if you did this in elementary school, you see that there is a 2-digit number and we must use another 2-digit number to divide. Okay, not the 4. You can't take a 4 and put it into a group of 12. You don't have enough. So you have 45. The question remains, how many times can we put in a 12 into 45 without going over 45? The answer would be 3. And so what did we do when we practiced this in our prerequisite skills? You multiply. And 3 times 12 gives you 36. And what do we do with that? Of course, we are subtracting whatever that number is. 5 minus 6, can't do that based on whole numbers. So it's 15 minus 6, that's a 9. 3 minus 3, that's nothing. So technically, you're done. But we're not dividing a 45. We're actually dividing a much larger number. So we drop down the 8. Now dealing with 90. Let's ask the same question. How many times can I put in 12 into 98 without going over? 5, 4, 3, 2, 1. The answer is 8 times. So we're gonna 8 times 12. Ooh, choose 8 times 12. That is a 96. And of course, I'm subtracting. 98 minus a 96 gives me a 2. And we ought to be done, but we're not actually dealing with 458. We're dealing with 4,583. So we got to bring that down. 28. How many times does 12 go into 28 without going over? 2. So again, oh, wow. They got that on record too. I don't know why it's on 8. That's a 3. How many times does 12 go into 23 without going over? That's a 1. And so, sorry about that. So silly. Man, that's on record too. It's like we're recording this. 3 minus 2, that's a 1. 2 minus 1, that's a 1. The remainder. So some teachers said you have to write the remainder here, saying remainder 11. But you don't have to do that. I am going to label this. So why did I do this elementary example? I'm going to use this to introduce some new terms that we will be using quite often. Okay, so it's a green, right? Yeah. The number that we divided from, we call that the dividend. And the number that we used to divide is the divisor. I don't know why it's called divisor as opposed to divider. Don't ask. The answer that we get from this question, you ought to know, is quotient. You know, because if you add, the answer is sum. If you subtract, the answer is difference. Multiply, product. Divide, quotient. And lastly, the final bit that we can't do anything with is the remainder. Why am I specifying these words? It's a little easier to describe this, I guess, operation or this calculation if I have words to communicate it with, okay? So as a division statement, you could say, based on this calculation, that 4,583 is the same as or equal to 12, groups of 12, times 381 of those groups plus 11 left over, right? So you can say the dividend equals divisor times quotient plus remainder. So that's what we call a division statement. So whatever number we have is equal to a multiplication of two things plus whatever's left over. Now, I can also write it in a different way called a quotient statement. So let me write it out in English, and I'll show you what that looks like in math. Because it's actually not anything new, right? I'll write it this way first. Dividend divided by, so quotient, so we're dividing, okay? Dividing by the divisor is equal to my quotient plus remainder divided by the divisor. Now this looks like something new that you might have to memorize, but that's not true. If you know your algebra, you already know this. Let me explain. 4,583. If I write this dividend divided by the divisor, what's my answer? 381 plus 11 over 12. And look carefully, isn't that just algebra? Like, take both sides of the equal sign for the division statement. Divide both sides by 12. 4,583 divided by 12. And that divided by 12, that 12 cancels out, and 11 divided by 12 is it's just algebra. I'm hoping that no one gets confused by that. It's a very straightforward manipulation of division. So if you know division right here, then you can figure out quotient, not a problem. So if you know division, it's just a little manipulation divided by the 12. Any questions so far? Okay. If this is true, I can argue that even if I have an x value there, the x is just a number. X plus 1 is just a number. Of course, it's a little more complicated, but instead of giving you actual numbers, I can now give you functions. You should technically still be able to follow. So here's my little tip for you. Starting off, I have a binomial. That means I need two terms to successfully divide. And what am I looking for? I am looking for some number, don't write this, that if I multiply to the divisor, I will be able to subtract and start getting rid of some of these terms. Let me demonstrate the first one. Your main goal is always to try to match the very first term. Let me explain. What do I multiply with x to get x plus x to the power 4? put that x to the power of 3 above the x3 term. Okay, try to match that. So x to the power of 3 multiplied by x is x to the power of 4. And then, of course, it's a binomial. So x cubed times 1 will give you 1x, x to the power of 3. I'll stop right there. Are there any questions about what the heck I just did? Yep. Sure. Do you remember how in the original equation question, whatever number I wrote, always multiply by the totality of that number? So it's 3 times 12, 8 times 12, 1 times 12. In the same way, I put an x to the power of 3 here, and it's going to multiply with all of this. It's sort of like saying x to the power of 3 times x plus 1. So you're going to multiply with everything and write the answer here, just like we did above. We have x to the power of 3 times x to the power of 1. X to the power of 3 times 1 gives you x3. And when I subtract, I'm circling that subtraction. It's very important. X to the power of 4 minus x to the power of 4, nothing. That's what we want. We want that nothing there. You don't have to write that. Next, 4x cubed minus x, 4 minus 1, 3x to the power of 3. Do you see? There's nothing here. That's your goal. Unfortunately, I'm not dividing just a binomial here. I also have the next term ready to go. So once again, my goal is to find a number that will get rid of the first term. Thoughts? What do I multiply with x plus 1? How do I get 3x cubed?
X squared.
Just x squared? You're close.
3.
There you go. 3x squared times x is 3x cubed. And 3x squared times 1, 3x squared. And please remember, it's a subtraction of the entire thing, not just the first term. I'm intentionally writing those brackets because a lot of people make careless mistakes. Don't want you to trip up. You look like I'm crazy. Ask a question. No. Or you're looking like I said something crazy. Okay. Bridget? You'll have to, once again, you're always trying to get rid of the very first term of your polynomial. So here, I have x to the power of 4. What do I multiply with x to get x to the power of 4? You always think that. Next, I have 3x cubed. What do I have to multiply with the x to get 3x cubed? It's always going to be focused on the very first term. That's where you always look. That's where you'll get your clue. Yes, Lydia? Adding the quotient-like terms? Oh, yes. A positive 3 multiplied by a positive 1 gives you a positive. That's where it is. So you treat it like a regular polynomial, like 3x squared multiplied by x plus 1. 3x squared multiplied by x plus 1. Okay? Oh, subtraction 3 minus 3, that's nothing. Very good. And negative x squared minus 3x would be negative 4x squared. And I wish I was done, but we have this. So just because you asked last time, Bridget, do you want to take a shot? your focus should always be on the first term. Perfect. Good for you. Negative 4x times this binomial gives you negative 4x squared. Let me draw the arrow. Negative 4 times 1, negative 4x. There it is. I am subtracting all of it. Gives me 0, once again, very happy. And negative 16 plus a 4, that's negative 12x. Finally at the end. Whew. Ethan, you want a shot? You want a shot? No? Well, I'm going to ask you to look at this. The first term is a 12. Negative 12. Something times x is negative 12x. What am I dealing with here? Yeah, that's your number. Negative 12 times your x is negative 12x. And negative 12 times 1 is negative 2. I'm subtracting everything. And if you did it right, negative 4 would be minus 2. There's your remainder. Okay, let's go with the full distance, division versus quotient statement. If I have this, I'm just going to call the dividend as f of x, because I don't want to write all that. The f of x is equal to the divisor, which is x plus 1, times the quotient, x cubed plus 32x squared minus 4x minus 12 minus 2 as my remainder. And quotient statement is whatever the dividend was over the divisor, and the answer is x cubed, the quotient right here, and the remainder is funky. It's the remainder divided by the divisor. And, you know, as a restriction, just slowly reintroducing it back to you. X obviously cannot be a negative 1, otherwise you're dividing by a 0. Can't have that. Okay. There's a couple of things I could all continue talking about, but this is where I'm going to give you a little sneak peek into why we're doing this. The whole point, as I said, was learning how to graph more efficiently, and we need the zeros. That's very messy, yes? The division statement. What if my remainder happened to be a 0? That just was gone. What did you just do? If that number, negative 2, was actually 0, the remainder was a 0, what did you just do? What if this was just, there's nothing there? What did you just do? Not the, well, yes, it's the answer, but what is this mathematically in grade 10, in grade 11? What did you just do? You factored a quantity. That's what we're trying to get at here. We're looking for special cases when the remainder is a 0. Right now it's not, and we have to learn this thing called remainder theorem. But when that remainder is a 0 is where we want it, okay, in the future. Yes? Did you say factor what? Factor 4? Factor, well, this is factor, right? You have a bracket times a bracket. It's factor form. And so if the remainder wasn't there, essentially what's happening is you factor. And that's where we want to be Friday. Okay, I'll show you. So this is a sort of a sneak peek into what's happening. And clearly this is very long. I'm going to give you a shortcut called the remainder theorem to help you find this very quickly. For now, let's suffer a little bit more, okay? Couple of conditions when you're using long division. What if I was really mean and I gave you, you can turn the page, What if I was really mean and I gave you a function that wasn't in order and also not numerical? Consider this. Power of 4, power of 3, and then power of 0. 2 is missing. You can still divide. You must create a placeholder. Whether it's here or here, put the coefficient as a 0 and write it in numerical order, largest to smallest. The same applies for the divisor. If I give you the divisor g of x here as square, 1, and then constant, rearrange it and do what we've done until now. Yes? By long division, want to not complicate. Remember, every time we put a number up here in the quotient, we're multiplying and then applying it here. We're multiplying and then applying and multiplying and applying, right? You don't want numbers all jumbled up. It will make things very unnecessary. Okay, just always write it in order. So here we go. I see this is a trinomial, so I need 3 terms if I want to divide successfully. I'll do it very quickly. What do I multiply to get into to turn it into a negative 3x to the power of 4? You write here, it is a 3x squared. And you write it on top of the same degree. Multiply, and I get negative 3x to the power of 4 plus 3x cubed plus 9x squared. And all of that is being subtracted. And here's your exposure to subtracting a negative. Negative 3 minus a negative 3. That's going to be a 0. Okay? X cubed minus 3. Negative 2x cubed. And 0 minus 9. Negative 9x squared. Bring this down. I have 2x. You see now, the degree is always going to be going down chronologically. It really helps with calculating. Moving on. Negative x squared times something gives you a negative 2x cubed. Answer, positive 2x. So let's multiply. Negative 2x cubed, positive 2x squared, positive 6x. Negative 2 minus a negative 2, that's a 0. Negative 9 minus a 2, that's 11x squared. 2 minus a 6. Lastly, this will be positive 11. Negative 11x squared plus 11x plus 33. Ethan, let me erase this. Just give me a second. Giving me a 0 once again. Negative 4 minus 11 minus 15x. And negative 19 minus 33 minus 52. There it is. By division statement, I'm just going to go through it very quickly because, again, it's just a repeat of what we had before. No need to explain. We've got f of x, so the dividend equals the divisor multiplied by the quotient. The quotient, the answer was 3x squared plus 2x plus 11. And the remainder is, just in case people make silly sign mistakes, plus and minus, I'm going to do, you're adding the remainder, which happens to be a negative. Yep.
It gives you g of x as the
Sure. Yeah. You know what? I'll show you here. If this was g of x, which is a divisor, f of x divided by the divisor equals 3x squared plus 2x plus 11 added to the remainder over g of x. There you go. So that was a big spiel. There's one little condition that I'm going to talk about, but I'll wait if there's any questions for me. Are we good? Any questions? So some of you might be like, oh, I've never done long division before. That's a little complicated. You're going to have to practice a little bit. Okay? There's no getting around that. Just keep on practicing. What is the condition for using a long division? Essentially, there is no condition. As long as you put the numerical order in tow, you have placeholders like a 0, you're good. There will be situations where you want to get the remainder very quickly. As I said earlier, I just alluded to the where we want to be on Friday. We want the remainder to be 0. So sometimes it's really nice if you can quickly figure out what the remainder is without going through all of this work. Because let's be honest, this is a lot of work. Yeah? Introducing the remainder theorem. Here is a textbook definition of what the remainder theorem is. And oftentimes, let's say you go to university and the professor's not very good at teaching, you'll have to teach yourself using textbook lingo. Here is textbook lingo. Please read this and see if you understand what that means. When a polynomial function is divided by a linear binomial, so what we've been doing so far, right? Like this one, x plus 1, that's a linear binomial, x plus 1. The remainder is equal to P of B over A. I'll give you like 30 seconds. Try to figure out, wrap your head around what that's supposed to mean. Thoughts? Give it a shot. Yeah.
Function times the second term of the binomial divided by the first term of the binomial.
Not multiplication. That's a function notation.
Oh.
Want to give it another shot?
No.
All right. What does this mean? Look, if my binomial, like the first example, if x equal, x is equal to b divided by a, but can you make sense of what we're trying to connect here? Jay? Yes. Do you recognize b over a from here, from your past? Not quite. I mean, I'm not trying to do mx plus b. If I have a binomial, like a factor here, where did you see that? Audrey? I know what you're saying. It's really like b over 2a, the negative, the shortcut? Not quite. It's the root. b over a is what makes that bracket or factor equal to a 0. Let me explain. It's better if I use an example, okay? Let's write this out. For this question, go back to the front page. Okay. The divisor is x plus 1. If x equals -1, that factor becomes 0. Does that make sense? Do you remember how we were talking about parabolas? You know, if that's a -1 and that's a 2, in your equation, it should be x plus 1 and x minus 2. It's that same concept. If what you are dividing by is x plus 1, and the root, therefore, is -1, therefore, okay, therefore, the remainder for f of x divided by g of x is equal to f of x with -1 plugged in. And I'll demonstrate that. This is what I mean by shortcut. If I do long division, have dividend, divisor, quotient, and remainder. If the remainder is all you are interested in, use the remainder theorem. What is the remainder theorem? Find the root, plug it into the function, and get the remainder. Let me demonstrate. You ready? Let's calculate f of -1. The equation is what? X to the power of 4. So -1 to the power of 4 plus 4x cubed plus 4x cubed minus x squared minus x squared. I'm going to run out of space. Minus 16x minus 16x minus 14. Minus 14. So -1 to the power of 4, +1. -1 to the power of 3, -1 times 4. -1 power of 2, positive. Times negative. Go. -16 times negative, that's a +16, minus a 14. 1 minus 1, that's a 0. 16 minus 4, that's a 2. -4 plus 2. -4 plus 2 is -2. What? Okay? So if you need the answer, if you need a quotient, that's one thing. You gotta calculate it. But if you're interested in just the remainder, plug in the root, and I'll give it to you immediately. Yes? As when we get to Friday, we're checking to see if the remainder will be 0. Very interested, and we want the remainder to be 0 because then we're like, yay, we can factor it. That's where we want to be. Yes?
Instead, like, I think we should be going straight to like, or doing out.
Well, you'll see me take this and blow it up a little bit more tomorrow. For now, I think my expectation is please know how to do long division and know what the remainder theorem is, like how to actually use it in a question. Yes. Great question. Oh, say what?
How should we do the next one?
For example, 3. Great question. Try to use the remainder theorem here, please. There's more than ax minus b long. So is the divisor a binomial? the remainder theorem is limited to just binomials. Long story short, you can add this. You can say g of x is not, or g of x is not equal to a binomial, therefore cannot use. As in, turn this binomial into two binomials and divide it separately? Absolutely you can. But that depends on your ability to factor first and do that properly. Yes, absolutely. Okay. So here's just another condition that you ought to know. The a value is 0. That makes sense because if you have a 0 times x, that doesn't make any sense. It's just a constant number, right? The b value also has to be an integer. That z as in integer. We do not want to deal with fractions here. It just complicates things. So the condition is make sure that it's a binomial. That's not a 0. So there's a number there. That is not a fraction. It's a whole or an integer value. And what you're dividing by is a binomial. If it's a binomial, which it typically is, you can calculate your remainder. That's essentially as far as I got for the other class as well. So we're a little bit faster. Why don't you try this before you leave? Here's like a quiz question. Without dividing, what is the remainder if f of x is divided by g of x? Okay, just letting you know. I'm checking. What makes 4x minus 3 equal to 0? You figure that out and use that for the remainder theorem. Don't be afraid of fractions. You might get a messy number, but trust you're doing it properly. Okay? I guess my task to you is I would rather for homework you try as much of this as you can. I think I assigned just the first couple of questions from the textbook because we're going to do more tomorrow. I don't want to overwhelm you for the first part. Try to do the questions that I've written here for you, and we'll take it up tomorrow if you have trouble. Now, I want to stop the video. Any questions? Yeah, or maybe individual question. Let's try that first, and we'll go deeper tomorrow. Okay? And stop.